Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Dear students, I have almost introduced most of the books to be followed in our next video lectures. However, still a few books are remaining, and I shall upload a video about those books at some later stage. Okay. Anyhow, now I am going to start modern physics problems. Okay. These problems will be solved with an intention to get some basic knowledge about the concepts of these problems. Okay. So we will use mathematics as our tool of understanding concepts of physics and mathematics. Okay. So dear students, this problem has been selected from the book Modern Physics by Kenneth S. Crane. Okay. Our remaining problems will be in this format. Okay. I have introduced a new thing in this new design of my video, in which helping tools will be used or utilized. Okay. Actually, dear students, by using helping tools, we will be able to work less on our solution of the problem, and we will just give a reference of the helping tool. Okay. So this is the problem. Okay. It is not necessary that I read this statement from find to electron volt per speed of light c. Okay. It is being seen on the screen. Okay. Even if I do not read it, it will be quite acceptable. But anyhow, as a formality, I also first read the statement, then I will come towards helping tools, and then I shall come towards solution of the problem. Okay. So that by giving reference to these tools, we will be able to proceed rapidly. Okay. And in this way, I hope my speed of uploading video lectures in this format will also be increased. Okay. So anyhow, dear students, this problem is regarding photoelectric effect, in which we are going to find out momentum. Okay. So statement of the problem, which has been selected from the book Modern Physics by Kenneth S. Crane, is: find the momentum of a 10 million electron volt or mega electron volt gamma ray, a 25 kilo electron volt X-ray, a 1.0 micrometer infrared photon. Okay. Dear students, this mu is the symbol for micro. Okay. In place of this, if n is written, then it means nano. Okay. Anyhow, a 150 megahertz or million hertz radio wave photon express the momentum in kilogram meter per second and electron volt per c, that is speed of light. Okay. So dear students, actually we have to find out 8 things. Okay. 8 things. Yes, because 4 parts D, and all the 4 parts have to be answered in 2 units. Okay. So we have to find out 8 things. Okay. Now dear students, we first come towards helping tools which will help us in solving this problem. Okay. So first tool, helping tool number 1 is in which a momentum of a photon is defined. Okay, momentum of a photon P is equal to E over C, where E is the photon energy and C is the speed of light in vacuum. Okay, this is alternatively equal to HF over C. Okay, where H is Planck's constant and F is the frequency. Okay, and this is alternatively equal to H over lambda, where lambda is the wavelength. Okay, dear students, this is a snapshot taken from some book. Okay, as you have almost come to know that I have introduced hundreds of books. Okay, so definitely this snapshot regarding the definition of momentum of a photon will also be taken from some of these books. Probably here I can guess that perhaps this snapshot has been taken from the book University Physics by Young Friedman. Okay, anyhow, other book may also be, but actually this is the pattern of that book. In addition to Young Friedman University Physics, Richard Wolfson Essential University Physics is also on the same pattern. Okay, now we move to tool number 2. Okay, second tool of our problem, which will help us in finding our solution. Okay, this is the conversion factor. Okay, dear students, here which value we will use? We will use the last value, this value. Okay, 1 electron volt is equal to 1.602 into, okay, here dot is used in place of a sign of multiplication. I usually use cross sign or X sign for multiplication. Okay, however here dot is used. Okay, 1 electron volt is equal to 1.602 into multiplied by 10 raised to the power minus 19 joule. Okay, so I think this tool has also been discussed in detail, because only last value is going to be used in our problem. Okay, now we move to our next helping tool. Okay, dear students, this is the next helping tool in which a few values will be used. Okay, first of all, speed of light. Okay, this will also be used. Okay, 2.998 into 10 raised to the power 8 meter per second. Okay, this will also be used. Moreover, Planck's constant, this is given in equivalent to units. Okay, 1 joule second and 1 electron volt second. Okay, so both of these will be used in our problem. Okay, sometime we will apply this first value in terms of joule second, and sometimes we will apply the second value in terms of electron volt second. Moreover, here dear students, in the last here HC is also given, but even if it is not given, we can find out. Okay, we have both values N, H and C, and when we will multiply, we will get this value. Okay, so this thing, despite that it is being given in the table, but even if it is not given, we can find out this. Moreover, 1 electron volt is equal to this. This has also been used in previous table and here once again. So it is more helpful. This table is more helpful. Okay, dear students, next helping tool number 4 is about prefixes. Okay, because dear students, here in this problem, kilo, million or mega, micro, nano, x are used. So this table is also shown here. Nano, for which n is used, is 10 raised to the power minus 9, while micro, which is denoted by mu, is 10 raised to the power minus 6. Okay, similarly kilo will be 1000, this kilo 10 raised to the power 3. Okay, anyhow, now we move to next tool. No, only these. Now tools were only these. Now we come towards solution. Okay, dear students, now we come to our solution of part A. Okay, here E is given in the problem 10.0 million electron volt. 10.0 million electron volt. 10.0 million electron volt. Here in place of million or mega, we use 10 raised to the power 6 electron volt, and this becomes equal to 10 raised to the power 7 electron volt. Okay, here one of the value to be calculated has been found. Okay, in terms of electron volt, but here next we have used conversion factor. Okay, when we have used conversion factor, then it will be multiplied by this value which is given in the table of conversion factors, and this energy will become equal to 1.602 into 10 raised to the power minus 12 joule. Okay, now we move forward. Now dear students, also as per tool number 1, in which definition is given of the momentum. Okay, also P is equal to E over C, value of E over C. Okay, this becomes equal to 10 raised to the power 7 electron volt. Over here we have used value of C. Okay, 3.00 into 10 raised to the power 8 meter per second, and this has become equal to this, and this has become equal to this. Here dear students, it will become Newton meter. Okay, over meter over second. Here meter will be cancelled out with meter, and we will get Newton second. Okay, 0.534 into 10 raised to the power minus 20 Newton second. Okay, and we know that Newton is equal to kilogram meter per second square. The second square, out of second square, 1 second will be cancelled out with S, and 1 second will become in the denominator. Okay, so we will get 5.34 into 10 raised to the power minus 21 kilogram meter per second. Okay, so other value in terms of kilogram meter per second is also reached. Okay, now we move to part B. Okay, here once again energy is given as 25.0 kilo electron volt. Okay, kilo means 10 raised to the power 3, that is 1000. So this will become equal to 25,000 electron volt. And here we have used conversion factor, that 1 electron volt is equal to this, in order to convert it in joule, and so we will get this value in terms of joule, and it will take the shape is this. Okay, because we have converted 40,015 to 4.0, so this power will minus 10 raised to the power minus 19 will be reduced to 10 raised to the power minus 15 joule. Okay, next part which we have to find out in terms of kilogram meter per second. So same pattern or procedure. Also P is equal to E over C, electron volt over C, speed of light is equal to 25,000 electron volt over 3.00 into 10 raised to the power 8 meter per second. What we have done, we have just used the value of C. Okay, so it has taken the form this. It will take the form as Newton meter over second. Meter will be cancelled out with meter, and we will get the answer in Newton second. And we know that Newton is equal to kilogram meter per second square. 1 second will be cancelled out with this second, and resultantly second will appear in the denominator. Okay, so in terms of kilogram meter per second, we have got the answer 1.333 into 10 raised to the power minus 23 kilogram meter per second. Now we move to next part C. Here wavelength lambda is given as 1.0 micrometer. Okay, here nu is the sign of micro. So in place of micro we have used 10 raised to the power minus 6, because nano is equal to 10 raised to the power minus 9, but here it is a micro 10 raised to minus 6. Okay. Next, we also know that P is equal to H over lambda. H, value of H is given in the helping tool table, so we have used that value, and lambda is given in the problem, that is 1.0 into 10 to the minus meter. Okay. So here joule second per meter will take the form as this will become Newton meter second over meter. Okay, here meter will be cancelled out with meter and we will get a Newton second, and Newton is equal to kilogram meter per second square. So 1 second will be cancelled out with this second, and second will appear in the denominator. So value of a potential P has become equal to 6.626 into 10 raised to the power minus 28 kilogram meter per second. Okay. Now dear students, lambda is equal to 1.0, micrometer is equal to 1.0 10 minus 6 meter. Also P is equal to H over lambda. Here we have used the value of H in terms of electron volt second. Okay, I had said that the value of H is given in terms of electron volt second as well as in terms of joule. Okay, so here we are using the value of H in terms of electron volt second, and value of lambda is given already. This has taken the form as electron volt second per meter. Okay. So dear students, here next step is that we have divided and multiplied it with the C. In the numerator we have taken the value of C, while in the denominator we have just taken C in terms of C. So here dear students, because we have to find out the value in terms of electron volt over C, so if we multiply and divide it by C, then there will be no change in the expression. So we are just reshaping this result. Okay. So this has taken the form 12.39972 into 10 raised to the power minus 11 electron volt per C, and it will take the shape as 1.2399728 electron volt per C, and this is equivalent to or approximately equal to 1.2 electron volt over C. Okay. Now we move to our last part D. Here we will use the value P is equal to HF over C. Okay, because this equivalent relation is also given in the first tool which defines the momentum, okay, of a photon. So here this is the value of H in terms of electron volt second, and this is the value of frequency which is given 150 million hertz or megahertz. So here in place of million or mega we have used 10 raised to the power 6, and this is simply hertz. Okay, not million hertz or megahertz. Okay. So it will take the form as this electron volt over C, and this will take the form as 6.204 into 10 raised to the power minus 7 electron volt over C. Okay. So in next part, P is equal to HF over C is equal to this into this over C, this electron volt over C, electron volt over C. Here dear students, okay, this has taken it shape as a joule second per meter. Okay, 3.315 into 10 raised to the power minus 34 joule second per meter, and it will take the form as Newton second, because joule per meter is equal to Newton, so it will take the shape as Newton second. Okay, and we know that Newton is equal to kilogram meter per second square. So this second will be cancelled out from second square, and second will become in the denominator, and our answer will be 3.315 into 10 raised to the power minus 34 kilogram meter per second. And this is the end of our video. Till next video, Allah Hafiz.